Ever stop and look at a sunset? Wonder why there are so many colors when the rest of the day the sky's just blue? It all has to do with light. Light from the sun looks white, but it's really made up of all the colors of the rainbow. You may have seen sunlight sparkling through a sprinkler in the yard or a fountain in the park, and a rainbow suddenly appears. The water helps to separate the sunlight into different colors, but you don't have to wait for that to happen. To see all those colors, take a prism, a specially shaped crystal, and shine light through it. When a ray of light enters the prism, the light slows down and bends. Different colors of light bend different amounts, so the light will separate into all its colors. All light travels in a straight line, unless something gets in the way and reflects it, like a mirror, bends it like a prism, or scatters it like the molecules of the gases in the atmosphere. Sunlight reaches the Earth's atmosphere and is scattered in all directions by the gases and the particles in the air. Blue light scatters more than the other colors because the blue waves are shorter and smaller. That's why we see blue skies most of the time. So why do sunsets sometimes look yellow and orange and red? Well, as the Earth turns and the sun gets lower in the sky, the light from the sun has to travel through more atmosphere to reach your eyes. This means there's more time for the light to scatter. Even more of the blue light is scattered, but the reds and the yellows, which travel in longer waves, don't scatter as much. So, more of those colors pass straight through to your eyes. But why is it that no two sunsets look alike? Let's talk to someone from NASA who's studying sunsets and what those colors can teach us about our atmosphere.
As the sun sets, the atmosphere absorbs certain wavelengths and it also scatters certain wavelengths. So what you can tell from that absorption and scattering is how much of certain gases or aerosols or dust you have, because as it sets, you're following it through the thin part of the atmosphere down to the very thick part of the atmosphere where we all live and breathe. And so you can actually see a beautiful profile of aerosols and gases, water vapor, and ozone. So you can tell where in the atmosphere those are most prevalent or most, the greatest amount of that resides.
SAGE stands for Stratospheric Aerosol and Gas Experiment. It measures ozone, aerosols, and other particles and gases in the atmosphere. The SAGE instrument makes its measurements by using the sun or the moon as its light source and seeing all of the particles in between it and the light source. So when SAGE is looking at the sun or the moon as its light source, the way you would be looking at a sunrise or a sunset or a moonrise or a moonset, we see the colors, but SAGE sees gaps where particles are blocking out the light. And that's how it knows what is there and how much of it.
Here on Earth, you only get one sunrise and one sunset every day. So there are only 2 times you can make that kind of measurement with an instrument on Earth. But a big part of science is getting a lot of repeated measurements and taking those measurements over time. So how does NASA plan to get a lot of measurements? The answer is up there, with a ride on the International Space Station.
So the ISS orbit is only 90 so minutes, so you're going around the Earth a lot in one day. So we can get several sunrise and sunset events in one day because you're seeing the sun each time you come around. So you can see the sun rising on one side and see the sun setting each time you're going around the Earth. The reason that the ISS orbit is ideal for SAGE is because you can see a large portion of the Earth. So from the equator up and down, you can see almost the whole Earth as you go around instead of just one spot on the Earth.
We want to have these SAGE missions because we want to be able to learn more about the air that we breathe and be able to take better care of our atmosphere and our Earth. These SAGE missions are continuous over a long period of time, and having that long period of data about ozone and aerosols gives us a better understanding of the big picture. This is one piece in the puzzle of understanding our atmosphere.
So now you know why sunsets can be so colorful and how NASA is using SAGE 3 and the International Space Station to help us learn even more about our world.